Hardly a week goes by without somebody talking to me or talking in the comments stream about signals. And it's almost always about React and signals. When will React get signals? React sucks because it doesn't have signals. Should I use signals in my production React application? And by the way, my answer today is no way. If you want to use signals in production, there are lots of great options. There's Solid, Qwik, Angular, and coming up, Svelte and Vue and more. React doesn't support signals. And the way that folks have tried to do it so far has been pretty janky. So my answer now is no, for right now. And that answer isn't going to change after this video, even though this video is about how the landscape of signals has fundamentally changed because now there is a proposal to bake signals into the browser. The promise is that the frameworks that we love today would adopt those standard signals as a consistent way to model application state. And potentially, frameworks could even interoperate between each other by sharing state through signals. Mind-blowing. So there's a link in the description right down below to the proposal, as well as another good article that does some analysis and has some code that I stole for this video. But the proposal has a polyfill library, and I couldn't help myself. So I figured out a reasonably decent way of interfacing the proposed standards-based signals with React and another framework. And we'll get there. Be sure to stick around for the end of the video for that. You're not going to want to miss it. But in the meantime, let's jump into trying out these new signals with React. Oh, just one thing. This is not something you want to put into prod today. The proposal is still very early days. The interfacing code I'm about to show you is probably pretty janky. This is a video about what's coming next in JS and not what's for today. We good? Okay, let's go. All right, this is one half of the application that we're going to build. It's got a shopping cart on there with apples, bananas, and cherries in it. And we can add apples, bananas, and cherries. And then our total changes, we apply a discount, and then we get a grand total update. It's pretty simple. We're going to use Astro to build out this application because Astro allows us to have islands of interactivity. This React shopping list is such an island. And we get to try out different frameworks in the same application, which is going to come up handy as we add the second part of this application. In the meantime, let's go build out our Astro app. I'm going to use create Astro at latest to create Signals shopping cart. I'm going to start off with an empty template. I do plan to use TypeScript. I'm going to use it pretty relaxed. We're going to use just a few generics. I am going to install the dependencies, and I'm going to initialize a new Git repo. Of course, all the code that you're going to see today is linked in the description right down below. Liftoff confirmed. Let's bring that up in VS Code. First thing I want to do is add Tailwind. That's what I'm going to use for the styling. So to do that, I'm going to use the Astro add command and give it Tailwind. That's the integration for Tailwind. It automatically sets up Tailwind and integrates it into our Astro app. Astro integrations are awesome. Yes, we'll add Astro, and we'll get a Tailwind config file. These are the changes it's going to make to our Astro config, and that's it. Next, we want to try out React, so we need to integrate React into our application. To do that, again, we use Astro add and React. Now it's adding React to our list of integrations, setting up some TypeScript options, and that's it. Now, the next thing we're going to do is we're going to model our data. So let's go take a look at our application and see what that data is. So the data we have is the cart. That's going to be the items in the cart. We're also going to have a total that'll be computed from all of the items in the cart. We'll have discount. That's also a mutable piece of state. You can change the discount. And then we have the grand total, which takes the total, applies that discount, and there's your grand total. So let's go model that in Signals. Now to start modeling in Signals, I need to bring in the Signals polyfill. Just like so. And then I'll go and create a new file in source called global signals. Because we're going to define some signals, and they're going to be global. I'll import the signal class from signal polyfill. You instantiate signal.state to create a state-based signal. Let's try that with our cart. So we'll have an exported constant cart that just instantiates the new signal.state. So it's a state signal. So it can be get and also set. So it's mutable. And then we give it the initial value. So in this case, that would be apple, banana, and cherry at a certain number of count and a certain number of price. Now we want to compute total from that cart. So to do that, we instantiate a new signal.computed. We tell what we're going to create, which is a number. And then we use cart.get to listen to the cart, and when the cart changes, we run .reduce on that array, and we accumulate the price times the count. That gives us our total. Next up, we want to create some mutable state for the discount. What should we use for that? So we're going to use signal.state again because we want to be able to mutate that state, and we'll give it an initial value of 0.1, which is 10%. Pretty nifty discount. And now we want to compute the grand total based on the total with the discount. So what are we going to use for that? Well, we're going to use signal.computed. And again, we use that get function to get total as well as discount and multiply those together. .get inside of the computed is essentially how you subscribe to that signal. Now, if this seems vaguely reminiscent of recoil or Jotai atoms, you're not far off. If you're looking for a way to do a signal-style data structure in React today, Jotai or recoil might be a good way to go. So now that we have our data, we want a way for our code to listen to it. Now, if you look at the spec, they talk a lot about an effect function, except that there's no effect function in the library. What we have to do is create an effect function which allows us to listen to a signal in our framework. So let's go and create an effect function. To do that, I'll create a new file called effect.ts. And again, I'll bring in our polyfill. Next, I'm going to create a signal watcher. Now, signal.watcher in the subtle namespace watches signals. Why is it in the subtle namespace? Well, it's subtle because how you integrate signals into your framework, again, probably done by a framework author, not folks like us, is subtle. Therefore, it is in the subtle namespace. But we're going to take a kind of generic approach. So we need to create this process pending, which is called whenever a signal changes. Our process pending is going to go through any pending state updates provided by that watcher and then pull the data from the signal. It is a pull-based mechanism as opposed to you pushing out a change in signals land. The efficient way to go is through pull. And then we'll create the effect function. Our effect function will take a callback function. That callback function is going to be our integration with our signal. So it's going to say, okay, we're going to get data from the signal, and by getting it, we'll essentially subscribe to it. So in here, we are creating a new computed signal. That's going to be what the watcher is going to listen to. And inside of that, we're going to call our callback, which is again going to call more signals, again doing more subscriptions, and then we'll kick off that watch and get the first value. And then we'll return a function that essentially unwatches or unsubscribes from those signals. And that's part 2 of a 4-part connection to React. So let's create the custom hooks that are going to take our effect function and bring it into our React state ecosystem. So I'm going to create a new directory called React Components. And in there, I'm going to create a new hook called useSignal. And I'm going to bring in one hook from React, useSyncExternalStore. useSyncExternalStore is a very obscure library hook that is meant to connect React and its state ecosystem with external stores. Think Redux, Zustand, Jotai, any of those. So you got data somewhere else that you want to connect into React, and useSyncExternalStore is the mechanism that React has provided to do that connection. So the first hook that we're going to create is useComputed, since it's the simplest one. This is a custom hook that's going to allow us to get the value of a signal. So we give it a signal. So let's bring in signal. That gives us a type. So we'll turn that into a generic that will then export as the return value of this function. That keeps it end-to-end type safe. And then we're going to use that useSyncExternalStore. Now, our first function in there is going to call effect, so let's bring that in. Looks like we're now TypeScript error-free. Let's talk about how useSyncExternalStore works. useSyncExternalStore takes 3 arguments. The first is a callback. We'll get to that in a second. The second and third are snapshot getters. The first is the client-side snapshot getter. The second is the server-side snapshot getter. Astro does run in a server-side mode, so we need to provide that. Next up is that first callback. That is React giving you a callback function that then you call whenever your external store changes. So to do that, we're going to use that effect function. In there, we are going to subscribe to that signal by doing signal.get. We're going to have that get the value, which is then going to cache off locally in this closure. And then whenever this changes, that's when effect gets called. We're just going to call that callback and tell React that it has changed. And then React is going to call the snapshot function to get the new value. Now that we know how that works, useSignal, which is the mutable version, gets a little simpler. useSignal takes a mutable signal and returns a tuple. That tuple has the value, the current value first, and then second, a setter function. If that sounds familiar to you, that's because it's exactly the same API service as useState, except that the function doesn't take another function, but whatever. It's close enough. So how are we going to do that? Well, we're going to use exactly the same useExternalStore that we did with useComputed, but we're also going to provide a secondary function that just sets that signal when you call it. Okay, so there we go. Those are the two functions we need to connect our React code with our signals. Of course, we don't have any React code, so let's go and build that. So I'm going to create a new component in here called React Shopping Cart. And into there, I'll bring our fresh new useComputed and useSignal hooks that we just created. I'll also bring in our signals, cart, discount, total, and grand total, because we'll need all of those for our interface. Next up, we're going to build the cart list component. That's this entire section, including React Shopping List and the whole list of all the items in the cart and the total and the discount on all of that. So let's go and build out that component. So we're going to start off by using useSignal and useComputed where appropriate. So when it's a mutable signal, we'll use useSignal to go get that data, as well as any setters. We're not actually going to use the setters in this case. And then for the computed signals, we'll use useComputed. After that, it just basically comes down to a bunch of JSX formatting. Of course, all of this code is available to you for free in GitHub, and a link in the description right down below. But this is standard React stuff. It's basically going, putting a header block on the top, iterating through all the cart items, and then putting out the total amount and all of that. All right, let's slide down here towards the end, and then create our React Shopping List component and export it as the default. So for the moment, we're just going to have the cart list in there. Now let's go bring that into our Astro, import it, and then we're going to replace our body with a nice dark mode version and a flexbox that gives us a 2-column layout. Let's hit save and see how we look. All right, looking pretty good so far. Let's go and change the discount and see if it updates. We'll make it a 30% discount. Hit save, and there we go. We got a discount now of 30%, so it looks like we are listening to those signals. Take that back down to 10%. We're not giving away our produce. So now we want a way to mutate that store. So let's go back in a React shopping cart and create a button that we can use to add items to our shopping cart. We'll call that add product button. It'll take a name and a price for our product. And then we'll put up a button nicely formatted that just sets the cart items. We take the existing cart items and then we add our item to it and we create a new array to do that. As with every other state mechanism in React, all of this works off of referential identity. So in order to update the cart items, you need to give a new array reference because it's the reference that matters, not the contents of the array that matters. Now let's hit save, and then we'll go down here and add some buttons. Let's hit save, try it out. And there we go. Very nice. Okay, so let's take a look at where we are so far. So we have defined some signals, the base state of the application. That's section 1. We created an effect function that's going to get called back whenever any of the signals that we call when we are in that function change. We then connect that effect function to React using useSignal and useComputed, which use useSyncExternalStore to give us a callback. We then wrap that in an effect and call back whenever those signals change. And then finally, we connect that to our components using those custom hooks inside of our React components. Now, if you're familiar with other signal frameworks like Preact signals or Legend signals, those connect directly to the DOM in addition to providing this signals architecture. That's not happening here. This is using a very traditional React approach. Anytime any of those signals changes, the whole component that listens to that signal will re-render. So I would consider this a much safer approach, although again, not in prod. Now, as I mentioned, you can do this in other frameworks as well. And of course, we're in Astro, which means we can very easily bring in other frameworks. So who is our mystery framework guest? Well, it's Svelte. We're going to go and connect Svelte to our application. So now they'll both be working off the exact same code base. If I hit more discount here, we can see that the discount on the React side goes up, less discount, and everything works because they're both talking to exactly the same state store. So we have on the same page a React application, a Svelte application, and they are both talking through the same standard signals. How do we do it? Well, let's go and add our Svelte component. To do that, we are going to start off by adding the Svelte integration. We simply do Astro add Svelte. And that's it. Now we've got Svelte going. So let's make ourselves a very simple Svelte component. I'll create another directory called Svelte components. And we'll call this one discounter. We'll give it the Svelte extension. If you're not familiar with Svelte, all the files are named .svelte that are Svelte components. And we're going to import the mutable discount signal and then format it in our component. So all we're going to really do is discount.get and multiply by 100 and then take off any trailing zeros. So now let's go and bring that in our page. To do that, we'll first import it. And then down here, we'll add it as the second column. Take a look. And there we go. Now we've got our discount going over there. Of course, it's not mutable yet. So let's go and add some buttons to increase and decrease the discount. To do that, we're going to bring in two functions, more discount and less discount. And all we're going to do is use the native signal functions to set the value after getting the value and adding on either +1 or -1. Now this .get, .set stuff is fairly contentious. If you look at the proposal, some folks are saying in response to it that they would much rather have a proxy-based interface or something along that line. I personally don't mind the .set and .get, but if you feel like that's an important thing here, then you should go and comment on the RFC. All right, let's add some buttons for more and less discount. And now we can add more. Okay, I can see the discount is going up over on the React side, less, and there you go, that looks good. But we're not actually updating the discount on the Svelte side. So how do we do that? Well, to do that, let's bring in that effect function. Then let's create a local for discount value. And then we will use that in place of discount.get. Let's initialize that actually with discount.get. And then we'll use that effect function to set discount value whenever the discount changes. Let's save. And there we go, looking good. And you thought I was going to end it there. Surprise! No, I'm not. Actually, I was going to, but now I'm not because Jatin Ramanathan, who is one of the authors of the spec, had a look at this video before you got to see it and said, you know what? You really do need to cover direct DOM manipulation with signals. So who am I to question that? Let's try it out. So I go back into our components. I'm looking at the React shopping cart list. I'm just going to add another div down here. We'll put in there discount. And then inside that, we'll put a span with the discount value currently. And we're going to set that to a string. Just to make sure that if you use this with an object or an array, you don't blow up anything. Let's take a look and see what happens there. Okay, cool. That looks great, but of course, if we add or remove anything from that discount, we don't get any changes. So what we can do is we can go and bring in useRef from React, as well as effect. Now down here, we'll add a ref for our discount. We'll set it to that span. And then in our effect, we'll set the current text to that discount. We'll make sure that it exists. We'll add a little typing to the useRef to make it happy. And then we'll do another conversion to string. This is mostly about TypeScript at this point. All right, let's hit save and go. And now as we add more discount and less discount, we can see it directly updating that element in place. If we go over here to our DevTools and then go into React Components, all we really need to do is just hang out there because as we make changes, we can see everything updating. But as you notice, the discount is not actually updating. The updating is signaled by the bracketing around the component. Only the React shopping list is actually doing a re-render at this point. The discount is simply updating in place. Now I really should go and wrap this effect in a use effect. Let's go do that. Now I'm just going to cut this effect and put it in there as what we're going to call. The reason for that is that effect returns an unsubscribe, which is what use effect wants, so that's good. And we'll add in an empty dependency array. And looks like we're safe. Let's try it out. Fantastic. Awesome. Reasonably safe React signal updates without actually doing any re-renders. So thank you for the feedback, Jotin. And now back to our regularly scheduled conclusions. All right, as I mentioned at the outset of this video, this is what's coming next in JavaScript. It's not what we have today, so I would definitely not put this into production. But it is fascinating to see. We have two different frameworks collaborating on the same page over the same data. I find that the Signals API is fine. I like that Jotai/recoil API style. I'm a fan of that. But there you go. There is a first look at Signals, both in React and in Svelte, in their native form. If you like content like this, React, Next.js, advanced topics, be sure to go to pro-nextjs.dev. That's where I'm building my course on Next.js. It is in-depth, and I'm really excited about getting it out to you. In the meantime, of course, there are free state management tutorials and forms management tutorials if you sign up for the mailing list. I'll see you there. Of course, if you like this video, hit the like button. If you really like the video, hit the subscribe button and click on that bell, and you'll be notified the next time a new Blue Collar Coder comes out.